Hello guys, how are you doing so far? We are going to continue with the tutorial lecture today as we plan, and I think the last lecture we had was on lipid. We had lecture on fat and oil. So in our schedule we are going to continue with nucleic acid. We plan to be doing 4 tutorial in a week, and the next one after fatty acids is nucleic acid. I think Thursday nucleic acid, Saturday carbohydrate, Monday amino acid, and Tuesday fat and oil, and the cycle continue like that. So we have seen the introduction to nucleic acid, that is Biochem 219, and we have seen a lot. We have seen DNA and RNA, just introduction to DNA and RNA. So, and I said DNA is deoxyribose sugar, while RNA is a ribose sugar, and the only difference is on one carbon. The only difference is on one carbon. So see, support the difference. We have for this for DNA, we don't have oxygen in this carbon, while for RNA we have OH here. For DNA is only H, while for RNA we have OH in this carbon, right? We have OH. So this is the only difference between DNA and RNA. So, and the sugar is a ribose sugar, 5 carbon sugar. You can see carbon 1, 2, 3, 4, 5. So the sugar is a 5 carbon sugar. And so today we are going to continue with the nomenclature of nucleotides. Okay guys, this is it. So as you can see here, the addition of phosphate sugar to base produce a nucleoside. If the sugar is a ribonucleoside are formed. Like we have adenosine for nucleoside, we have guanoside for guanine in a nucleoside. Sorry, I did not indicate. I am talking about the nucleoside, not nucleotide. So when a pentose sugar, addition of pentose sugar to a base produce nucleotide. So if you have adenosine, as you can see, if you have adenine in purine base, you are going to have adenosine, and if you have guanine, you are going to have guanoside in terms of RNA, while in DNA we are going to get deoxyadenoside, or for guanine deoxyguanoside. Sorry, you can see this is for DNA and the guanoside is for RNA. This is for DNA, this is for RNA, right? So addition of only pentose sugar to a base, that is purine nucleotide, will produce a nucleoside. And in terms of pyrimidine, if you have pyrimidine, right, like cytosine you have cysteine, while for DNA you have deoxycysteine. For thymine you have thymidine or deoxythymidine. For uracil you have uridine. This is the nomenclature of nucleoside. So guys, what we just explained now is just a sugar with a phosphate. What we just explained now is a sugar with a base with a sugar. And now, when a single phosphate moiety is added to a nucleoside, this is our nucleoside. So when a single phosphate is added, we call it nucleotide. When a single phosphate is added to a nucleoside. So this is now our nucleoside, that is organic base with a pentose sugar. So now if we add phosphate to this nucleoside, we are going to get mononucleotide, right? Mononucleotide, like adenosine monophosphate. If we add a phosphate group to this adenosine, we are going to get adenosine monophosphate. Let me explain this step by step. As you can see here is a adenylate, right? We call it adenylate, right? As you can see here is a adenylate, but we also call it AMP. This particular adenylate, we call it AMP, that is adenosine monophosphate. That is, you add one phosphate group to a adenosine. If you don't want to call it like this, you can just say adenylate. If you don't want to stress yourself saying adenosine monophosphate, you can say adenylate. It's the same thing. And also called AMP. So guys, this is in terms of RNA, but in terms of DNA we call it D-adenylate. Deoxyadenylate, or if you don't want, you call it DAMP. Is the same thing, that is deoxyadenosine monophosphate. That is a base with phosphate sugar and a base with pentose sugar and phosphate group, right? So as you can see here, for guanosine we have guanylate, and in terms of DNA you can call it deoxyguanylate, or in other words you can say guanylate, you can say guanosine monophosphate or deoxyguanosine monophosphate. And for cysteine also, for thymidine also, and for urelate. Sorry, for uredilates. For uredilates, you can just say uridine monophosphate. You can just say uridine monophosphate because in DNA we don't have uridine, right? We don't have uridine in DNA. So I think for this one is okay. Note, there is small note here, you just need to read it. I think the next is structure of nucleotides. So, and I think the next is structure of nucleotides. As I stated already in the introduction, the nucleotide essentially consists of only nucleobase, sugar, and phosphate. And the nucleoside refers to base plus sugar, while the nucleotide is when you plus phosphate group. Then the purine and pyrimidine here are found in the nitrogen. The purine and pyrimidine, that's the nitrogen base, are aromatic cyclic compound. As you can see, they are just cyclic compounds. We have purine and pyrimidine. And the purine, as I mentioned, are number anti-clockwise direction, while pyrimidine are number in the clockwise direction. And also, purine contains adenine and guanine, while pyrimidine contains cytosine, uracil, and thymidine. Right, so I don't think I have a lot to explain here. Then also, this is just the structure of nucleotide and ribonucleotide and deoxyribonucleotide. So these two also I don't have to explain alone. So this is just additional adenosine monophosphate structures. So we have adenosine 5' monophosphate. We have adenosine 2' monophosphate. As you can see, this is in carbon 5 and this is in carbon 2. And we have adenosine 3' monophosphate. This is in carbon 3. And we have adenosine 5', 3' cyclic monophosphate. You can see also. So I think the next one, we just sugar. So just sugar phosphate backbone. The nucleotides are oriented in the same direction. The phosphate group join the 3' of one sugar to the 5' of the next sugar. This is where the phosphodiester bond is formed from between 5' of one sugar to the 3' of another sugar. So I want to finish this slide today so that we can continue with another one tomorrow. So the phosphodiester bond, the chemical bond that formed when exactly two hydroxyl group is in phosphoric acid react with a hydroxyl group on the other molecule, forming ester bond. This is the general explanation of phosphodiester bond. That is, all this is this bond. All this explanation is about this bond, and this bond. This is the bond that join one sugar to another sugar. That is why they say the bond that form when exactly two hydroxyl group in phosphoric acid react with a hydroxyl group on the other molecule, forming ester bond. This is the phosphodiester bond. So this is about writing the sequence. I told you before, the order of the sequence is 5' to 3' direction. So their order is important. it determines the genetic information of the molecule. Sequence is writing in 5' to 3' direction, right? Let's say you have C, T, A, T, T. Then you want to generate another sequence of DNA. You know, you want to this is the template, the template to generate another sequence. So you know, C pair with G and T pair with A. So we just say this is C, I'm sorry, this is G, this is A, this is T, this is A, this is A. Then you have already so you have generate another sequence. We are going to talk more about this when we come to DNA. You know, this is just introduction to this course. We are going to have a general explanation on DNA on DNA and RNA separately. So guys, I think this is where we're gonna stop today, gaskiya, because Chagall's rule need a lot of explanation, more clear explanation, and today I already speak a lot. I make noise, so I don't think we can continue like this. Like, I just wanted to have only 10 to 5 to 10 minute lecture, but a lot already like this I have 17 minutes. So I think I am going to continue next time, which from here I'm going to start from here next time. Okay guys, see you next.